So network address translation, again this is 473, but since I need it here, I want to make sure that you know it very well, is that whenever you have private network, you have private addresses, those addresses cannot be used as the source address on the public internet. Alright, so what you do is you put a network address translator here, and whenever something goes, it always goes with that source address, which is a public address. Everybody knows what is a private address, right? And what is a public address. So this is a public address, and you have only one public address, and so you just use all the computers have private addresses, and then you use that address. So the private addresses cannot be used on public internets, so the NAT overrides the source address. When you send a packet, the source it looks at the IP address and changes it, and then it makes a note. It sees, okay, well, I got a packet from 201 and it was going to that destination, and so when something comes from that, it sends it to 201. If it came from 202, it sends it back to 202. So, and there is a little more detail. Actually, it also changes the port number, because if there are two people going to the same destination address, and the response comes back, it has to know which one. So it looks at it changes the source IP and the source port number. Source port numbers are random. So the destination port numbers are standard. When you send an HTTP request, generally you have to send it to port 80. But you can put any number in the source port, and it doesn't matter. You might put 3043. Okay? It will change that number. The NAT will change it, and so in the table it has that, okay, this 3043 was from 201. When the response comes back, it has the same port number in the destination field, and it changes it back, the destination address to 201, and the source port number back to your 3043, whatever you had put. That's how the NAT works. The only problem with NAT is that only allows outgoing connections. It doesn't allow incoming connections. So for example, if you're running a web server here using port 80, if somebody wants to come to you, this box will not know where to send port 80 to, unless you program it exactly. That's what you do on a router, home router. You have to program that which computer out of your 10 computers gets port 80. No other computer can get that port. So you can do port mapping. But if you don't do port mapping, then the incoming things cannot possible. Only thing, when you send out something, you get the answer back. Send out something, get the answer back. So here's an example. There are two computers, one IP address, and so 201 using source port 8001 sends something. Doesn't matter where it sends to. So let's say here is the detail. 201 sends to 210, to this IP address, with the source port of 8001, the destination port of 80, so which is a web server. To this web server sends a request. The NAT changes the source address to the public address and changes the source port to a random number 3001 and makes a note. Actually, it's not a random number. It is smartly, it puts in by the row number. So it says, okay, in row number 3001, I have remembered this entry, so it will put that number here. And then the packet goes to the destination. The destination basically reverses these. So the source becomes destination, destination becomes source on both IP and TCP. So the destination is 216, which is the public IP address. The source is this thing, which is okay, and the destination port is 3001. Okay, and that is the key. So now when the NAT gets this packet, it looks at 3001 and looks at that entry, and it says, oh, this actually came from 201 with the port of 8001. It changes those two fields, puts the destination of 201 and the port of 8001. Okay, so now you see this source doesn't know that it really went through NAT, because it sent to whatever source and destination, it got the same thing back, similar thing back. So the NAT is hidden totally, is actually in that sense, if you want to call it in a ADC, because it is a service that it is giving, and that service is to use a single IP address. But so basically, this is how the NAT works. Now this is called Okay. Anyway, this is called NAT 44 because your internal private network is IP4 and the public network is IPv4. Alright, but it doesn't have to be. You could have an internal private address of IPv6. The public network could be IPv4 and the NAT will do the same thing. It will use tunneling, yes. Good point. Is that you cannot just change the address and send the packet because IPv4 routers will not understand the rest of the packet. So NAT 64 will not only change the addresses, but it will also encapsulate the packet so that everybody on the way will understand. Only the destination at the end will de-encapsulate it and then figure out what to do with this packet. But you can go through the public internet, IPv4 internet. Similarly, there is a NAT 46 which does just the opposite. So the technology basically, when it was designed by a graduate student at Stanford, IPv6, they asked him as to how you are going to support both B4 and B6. He says, I will put both these stacks in a single router. Okay, so the router gets it and they say B4 or B6 and that is what, okay, well that was really not very smart because nobody is going to buy two routers for the price, or going to pay the price for two when one will do. So that's why the V6 is having difficulty coming in, is because there is not good transition strategy. So anyway, the dual stack means that you implement both. So that is one alternative, is that you implement both in the router system. So right now, this is the situation in the world. Every host implements both. Microsoft Windows implements IPv6 and v4. I have this laptop in front of you. It has both IPv6 and v4. All right? But none of the routers do. When you buy a router, it either is IPv4 or it is IPv6. Because it's twice the cost. Well, it's not really twice the cost, but it's extra cost for nothing. So the idea is, the idea is that also there are lots of already routers in the world which are IPv4. They are not going to change them to make IPv6 because the fields are different lengths and everything else is different. It's not just firmware upgrade, it's a hardware upgrade. And why break something when it is working? All right? So these NAT kind of things will help because then you are just encapsulating and doing that, right? So this is a large organization of carriers transition. So now the carriers, particularly in the other countries where the IPv4 addresses are in short supply, are thinking what to do. So they have come up with carrier grade NAT. Carrier grade NAT means that they are going to use a NAT themselves. So they will have one IP address and they will give out their private address to everybody, not public address. Right now in the United States, when you go to AT&T or Cox or anybody, you get a public address generally. They don't make a much fuss about it. But if you go to some other countries, they don't have that many private addresses that they can give to whole city. So they have to give out private addresses. All right? And then that address actually, it turns out if they start giving 192, there will be a lot of confusion because everybody has 192. So they cannot use 192. So they went to IETF and said, please give us something which other people cannot use. So they have a carrier special private address, which is called shared address range. And that starts with 100. Okay? 100.64.0.0/10. Everybody understands how to read this /10? How long is the prefix? 10 bit is the prefix. So you just write this out and first take the first 10 bits. So first 8 bit is 100, and out of 64 you will get 01 because 8 bits is 127 and onward, right? So you get 01. So that's all there is a prefix. That prefix. So they can give out this number. So they can give out 1064.1.2 to this customer and 1.3 to this customer. Now this is, for all practical purposes, is a public address for this subscriber. It will have a NAT to switch to that, and then the carrier will have a NAT to switch to the real world.
There's a delay.
Huh? There is a delay. Everything requires time, right? But better than having no connection. Several concepts here. First concept is here you heard about shared address range. This is new stuff. Shared address range is 100.64/10. Second thing you heard is the carrier grade NAT. Third thing is NAT 444. So there are 3 4s here. 4, 4, 4. Now you could have other combinations. Can you think of other combinations? something like that, right? Here could be 6, here could be 6. Here it has to be 4 right now, in the middle. Because shared address range is only for the 4. Here's the reason why you don't need the 6 there. Because if you had a 6, there's no shortage of addresses. We could give it out to everybody. Right? We need these private addresses and we need these shared addresses only for V4. No, actually, so here's the thing. Anybody can fool anybody. So this is designed for the carriers, but there's no police on the internet. So you can use it, Vashu can use it, and police will not come. Except if suppose AT&T starts using it and Vashu uses it, it will have to be very careful that there is no confusion here. If AT&T is providing the service, here is the thing. Suppose this guy starts using carrier grade addresses inside here, there will be a lot of confusion because your neighbor has that address and you are sending out the packets. So yes, the carrier might police it. Carrier might throw away. Basically what this router will do is it will look, oh, is the address 1.3, it is coming from here, throw it away. Right? So of course the confusion will be there and the carriers can police it, but the internet doesn't have a police. Now, a good thing is that every carrier can use this 100. So basically, Cox can use it, AT&T can use it, and every carrier. So everybody doesn't need a private, doesn't need a location. They don't have to go to IANA to get, okay, what is the address you can use. Right now, they go to IANA to get IPv4 addresses, public addresses. Okay, so his point is, okay, let me explain what the point is. The point actually applies to all NATs, and let me go back to this. See, the thing is, this port number that this NAT used is 16-bit, and many of these numbers actually are standard. So for example, up to 1024 they are standard port numbers. You cannot just arbitrarily use them. If you use port 80 for something, there will be a lot of confusion when the response is coming back, because a lot of people will think that 80 is a web page. So you don't use that. You can use it. There is no reason that you cannot use port 80 as a source port, but by the way, you can use any number you want. But just to avoid the confusion, because firewalls look at port numbers. Alright, your firewall might be confused if you use the wrong port number. So generally you use only from 1024 up to 2 raised to 16. Alright, so his point is that you have approximately 2 raised to 16 port numbers, and therefore your NAT is limited to 2 raised to 16 computers. Alright, yes, that is true, but 2 raised to 16 is good enough. Here is the thing. In this carrier grade thing, we are almost reaching the limit, because this NAT has 2 raised to 16 subscribers it can have. Alright, 2 raised to 10 is 1,000, 2 raised to 64,000 customers it can have. 64,000 is not supported in all city. Oh, you can do easy. I mean, all you have to do is just create another carrier. I mean, you could have AT&T 1 and AT&T 2.
Oh, okay.
I mean, only one public address here, right? I mean, you don't want to put 16,000 people on one address.
I see.
All right, what you do is you put them on, totally slightly different box. All right, now we are back to our previous slide. Now that you understand NAT, we can talk about how you put load balancer. So the load balancer can just do dual NAT, which means that it does both sides. Now this name one arm mode, actually I saw some of the vendors, actually I should say, like, there are many vendors, Cisco, F5, many people who make these load balancers. They all use different names because these are not standard names. Okay, so dual NAT is Cisco name, one arm mode I forgot whose name it is, but there are other companies use other names. So there are 2 names. So it changes both the source and the destination addresses and the destination port numbers on the client request, like a regular NAT. So this is like a regular NAT, right? So what happens is when the request goes, the source address is different now. You see here, the load balancer says that the source is 168.0.1, which is me, right? And the port number is 3001. So when the server responds, it sends it to the load balancer. Load balancer looks up its NAT table and says, oh, it came from that host client and his port number was this and this. So it just does just like a regular NAT. That is called a dual NAT. The server sends a response to the load balancer, and the client and server can be on the same subnet. Okay, I think I am missing a NAT here. There are two disadvantages of this approach. First disadvantage is that the client and server cannot be on the same subnet. You know why? Suppose this has an address 192.168.2. Then when the packet is, 2, 3, 4 are used, let's say 5. When the packet goes back, it doesn't have to come to 1. 5 could just go directly. Right? And there will be confusion as to, what is the port number. I never sent on this port number 3001 anything. Right? So the clients and server cannot be on the same subnet. So it cannot be used for internal server to server communication. It can only be used with the clients outside. Please change that line, okay? When it comes here, it will change. So let me just think about it, okay? Is that it comes here on a VLAN in which this client is there and the load balancer is part of the same VLAN. Then the only packet it will come here, right? That is the only reason it will come here. Otherwise, it will not come to this. So load balancer is on the same VLAN as the client. And so now what will happen is it will change the source address. It will change the source port. Client and server can be on the same subnet. Maybe that is true. Okay, so let me all the story I made. Okay, so that is the positive part. The negative part is the second line. So positive and negative. Positive is the client and server can be on the same subnet, but the negative part is that the servers do not see the real client address. So when this server gets this packet, it thinks that the 01 sent it, which is why the servers want to know who sent it? Is there a reason they would want to know who sent it actually? Firewall. And security and other reasons. Somebody is not supposed to write, on this thing, right? So they really don't like that they don't know who sent it. That's the negative. This is actually okay here. So client and servers can be on the same subnet because here the thing, basically this will send it to this VIP and all the VIPs could be 192 here. Okay, it will get there and it is going to change both the addresses and both the addresses will come back here and they will go back to the place. So there is no problem here. There is no bug, there is no mistake in this slide. You understand the positive is that they can be on the same subnet, but the negative is that the servers don't see the real address which they want to see. They can be on the same subnet. This whole thing could be one subnet. Yeah, so I'm saying, suppose this whole thing is inside a data center, single data center, they could be on the same subnet. They could have same, private address range. NAT here is a load balancer. See, this is the thing. All I'm trying to tell you is the one way to load balance is by NAT, using a dual NAT. You don't need NAT for address translation. You are using the NAT technique for load balancing. Let's say everything is 192, but when we are declaring the address of this server, we are not publishing these addresses. We are putting 0.1. That is the VIP, virtual IP. So all the clients will come here. From here they will go to different servers. And then they will come back here and then go back to all the clients. So this works inside a single subnet. As you see the different techniques, they have this positive and negative. So the second one, which is called server NAT and called routed mode, in this one, it changes the IP address only but does not change the port number. So now what happens is server sends the response directly to the client. No change to the port number. Actually, no change to the source IP address either. You see? So the request is coming from this source IP and this source port. It is sent with the same source IP and the same source port, except the destination address has been changed to real IP. Alright? Now the server can send a response. It will just flip these two destinations and source and send it. So let's see, 216 is outside, the port number is 8001. Load balancer is made the default gateway. So the only way, okay, so the problem here is this packet has actually has to go through the load balancer, and the way it will go through load balancer not by the address, but because it is the default gateway. You know what is the default gateway? All the packets go through the default gateway. So now, if you make this a default gateway, so this packet will go there, the load balancer will look it up and say, oh, okay, this request had come from, so it will change the source address here, 210 to virtual IP. So basically, this source address 02, real IP, will be changed to virtual address 210. That's all it is doing. It's changing the destination here to private, and here changing private to the public. Public to private, private to public. That's all it is changing. No change to the port numbers. It's not even looking as to where it came from. It doesn't really need to know anything. All it needs to know is that it came from a public address, and I'm sending it to private address, and then whenever it comes back, it changes private to public. Yeah, in this case, so now let's see. So we are up to here right now. Load balancer is made the default gateway. All the requests go through the load balancer because of that reason, and the load balancer changes the source IP addresses on the responses as well. So this works only if the client and the servers are on the different subnet. So this will not work on the same subnet, because on the same subnet you do not go through what? If you are on the same subnet, you can talk directly. You don't need to go through the gateway. So this one requires that this be made a default gateway, and then only it will go through that one. But the advantage is the server can see the real addresses. So we flipped the advantage and disadvantages from the previous one. Alright, the last one and the last slide for the day is transparent mode, direct routing mode. All servers are programmed to respond to the same VIP. So now here we are manipulating the servers, and servers have two addresses, a VIP address and an RIP address. VIP address is 210 for all of them. Alright, now multiple people having the same address could be very confusing. So what they do is they tell the servers, please don't respond to ARPs. If somebody asks you what is your MAC address, don't even tell them, because otherwise they will get 3 responses and they will be very confused, right? So the servers have 3 VIPs. They have some real IPs too. That is what they really, if you want to manage them, if you want to change something, you want to tell something, then you use the real IP. So they have 2 IP addresses on the same port, 1 port, 2 IP addresses, 1 VIP, 1 RIP. VIP is used for the service and RIP is used for management. So when somebody sends, they send it to VIP, and the load balancer basically all it has to do is flip. Send it to 1, 2, 3, 4, 5, 3, 1, 4, 5, whichever, doesn't matter. So everybody has that same address, the answer goes back. Okay? And load balancer has to be something in common, because the thing is otherwise it will not know who to flip where, because it has to flip it back and remove the connections list and all that, right? So basically, sole layer 2 switch to the server NAT, it does not change anything. It does not change the IP address, port numbers, nothing. That's why it is transparent. Alright, I'm going to stop right here. The whole thing in this lecture today came from one book. The book is referred at the end, reading list. I would recommend that you read that.